the constant function. So the function f from set of real numbers to set of real numbers are defined by y is equal to fx equal to c, or c is a real number. It's called the constant function. And its value table is like this. So x value may be -2, -1, 0, 1, 2, etc. But y value always c. So it's a graph. The graph of function is like this. So in coordinate geometry, xy plane, O is the origin, then the point 0 c, that is x is equal to 0, y is equal to c, this point, and 1 c, 2 c, 3 c, and collecting all points, we have a graph y is equal to c. This is the graph of constant function. It is parallel to x-axis. So y is equal to c is the horizontal line. Means it is parallel to x-axis. And domain of this function is equal to set of all real numbers. Since we choose the x value from -infinity to +infinity, and the range of this function is equal to only single number c. So here this is c is subset of r. So when the range is the subset of codomain, r is codomain. That is, this f is into function. And f is many one. Many one because for 0 c, 1 c, so both 0 and 1 have c as a single element. So it is many one type of function. And its Venn diagram will be like this. This function f from set of real numbers to set of real numbers. So 0, 1, 2, or -1, -2, etc. But image is single c. So every number goes to c. 0 c, -1 c, -2 c. So all images y value is c. So this is Venn diagram for constant function. So the name of function is constant function. The table, we have a value table, and using this x, y coordinates, when you plot the 0 c, 1 c, 2 c, 3 c, all points available here is a parallel line to the x-axis. This is graph of constant function, and this is domain, this is range, and this is menu and into type. The identity function. So the function f from R to R is defined by y is equal to fx is equal to x is called the identity function, and its table of values will come like this. It's x value y. So x value 0, 1, minus 1, etc. Then y value equal to x. Then its graph of identity function comes like this. So 0, 0, 1, 1, 2, 2, 3, 3. When it join, we have this straight line graph, that is y is equal to x. This is graph of identity function, which is a straight line making 45 degree with positive direction of x-axis. This is graph of identity function, and its domain is equal to R, and range is also R. So when range is equal to codomain, then this f is onto type, and it is 1, 1 also. So 1, 1 onto, and so f is a bijection. This function is a bijection. Bijection means 1, 1 and 1. Projection and injection. It is a bijection, and its Venn diagram will be like this. Domain R, codomain R, f is a function, then 0, 1, 2, etc. Now image of 2 is 2, image of 1 is 1, image 0 is 0, image of minus 1 is minus 1, image of minus 2 is minus 2. This is Venn diagram. So absolute value function, also called modulus function. So the function f from R to R defined by y is equal to fx is equal to mod x, that is equal to minus x if x less than 0, is equal to plus x if x greater than equal to 0, is called the absolute value function. And its table will be like this: 0, 1, 2, minus 1, minus 2, like this. So 0 modulus 0, 1 modulus 1, 2 modulus 2, minus 1 negative, modulus is plus 1, minus 2 negative, modulus is plus 2. So we have these points in the graph. So graph of absolute dependent function is 0, 0, origin 1, 1, 2, 2. This points into first quadrant. That is y is equal to x. Y is equal to x for x positive or 0. And in the second quadrant, it is -1, 1, -2, 2. A straight line is y is equal to -x. Y is equal to -x if x is negative. And so this graph is look like V shape. This V shape is the graph of absolute value function or modulus function, and its domain of function is R. X value is R, and range of this function or y value is also only positive. Means the interval 0 to infinity, because y is only 0 or positive up to infinity. Y value not negative. So the graph remains above x-axis. Below x-axis y value negative. Here it has no branch below x-axis. So y always 0 or positive. That is why range of f is this. Now here range of f is subset of codomain. So f is, this function is many one into type function. And Venn diagram for this function so 0 modulus is 0, -1 plus 1, both modulus plus 1, -2 plus 2, both modulus 2, -3 plus 3, both value 3. So many one and into function. This absolute value function is otherwise modulus function. The graph is V shape. This is table, and domain range are R and 0 to infinity, and range of being subset of R, it is into type function, and it is many one because two x values have same y. So greatest integer function, also called floor function. So the function f from R to R defined by y is equal to fx is equal to square bracket x is equal to n for n less than equal to x less than n plus 1, where x belongs to R and n belongs to z set of integers. That means when real number x lies between n and n plus 1, let's say integer value is n, bracket value of x is n, the integer which is immediately left of the x. This is greatest integer function, and its table of values will come like this. So when x lies between 0, 0.1 0.9 up to 1. So between 0, its y value is remaining 0. 0 and 1, it is remain 0. And then after 1 or 1.2 or 1.9, its value remain 1. So for x 1 and less than 2, y value always 1. Then y value are integers. Similarly, -1, -0.9, -0.1, all the y values are -1. So the graph is like this. So between 0 and 1, y value is 0, graph is decimal. And between 1 to, the graph is 1. Between 2, 3, the graph is 2. So y is the constant, y is 0 here, y 1 here, y 2 here, like this. So between -1 and 0, the y value is -1. And between -2, -1, y value is -2. And between -3 and -2, y value is -3. So this is -1, this is -2, this is -3. So this is graph of greatest integral function, like this. So this is step function. This is an example of step function. Step is like staircase, and its domain is equal to R. Range is only set of integers Z, which is subset of codomain R. So F is main1 into type of function. And the Venn diagram for this, so between 0 and 1, the image is 0, and between 1 and 2, the image is 1, and between 2 and 3, the image is 2. So this is many one type of function.